Crafted here. I sold my lawnmower that I replaced with the John Deere. Remember the one I did the oil consumption repair on? And I let that daggone mower get out of here before getting my 1 7/8 ball for moving small trailers, jet skis, and stuff like that around. And well, I've got another 1 7/8 ball, and this wouldn't fit my other tractor, but it'll fit this one. It's got a 3/4 inch bolt, but this bolt doesn't go up very far. So, you know, the flange on the back of these tractors is basically just a piece of sheet metal. So I need to make a thick washer here. I don't have any washers with a 3/4 inch ID that'd be appropriate for this. And, you know, I didn't set these lathes up and work on these projects and buy all these tools so I could run to the store and buy washers and stack washers up and all that stuff. Man, we're going to make a custom part. Got my bar of aluminum that I picked up at the scrap yard, and I'm going to cut me a piece off of this, and we're going to turn 1 or 2 washers out of it so I can get this mounted up on my tractor. You can hear my sweetheart out there cutting the grass now. She's probably just about done. Alright, a lesson. How long do you think I need to cut this piece of stock to make this washer? Well, maybe only about this long, and then I could machine the washer out here. I might make 2 washers, one for top and bottom. But that's a mistake. I remember one time for my model airplane hobby, I bought a special piece of wire, and I don't remember how long of a piece I needed, but I bought a piece of wire that was maybe only 4 or 5 inches, 6 inches longer than what I needed, and then later on I needed another piece of wire, and I went and grabbed that piece of scrap. It wasn't big enough to make nothing. So when I cut this piece off, I'm not going to cut off just enough to make my washer. I'm going to cut off a stick of stock here, and I can get a lot of the stock in the chuck, and I can make my washer out here. And I'll be able to use this piece of stock, let's say 6 or 7 inches here, to make maybe several things. Who knows what I'll make next, because I've got enough to hold on to. Once you get down to where you don't have enough to hold on to, well, you really can't make anything in a lathe anymore. So it's not necessarily a savings of material to cut this to the smallest piece that I would need to work with. It's actually a waste of material, because the part that's left back in the stock just ends up being thrown away. Now, I'm going to have to start sawing on this, and the whole time I'm sawing on this, I'm going to be thinking about my Atlas cutoff saw that I haven't repaired yet, that I bought last winter. Did a back of the truck video on that. I've looked at it and picked at it a little bit just to kind of see if there was any parts I needed, but I haven't gotten serious about starting to work on it. So I'm going to have to use a trusty old hacksaw on this. I wonder if that blade will finish this job. Let's see. Well, yeah, that's about right. 6061 T6. Oh yeah, it's 1.5 inches, a little bigger than I thought. So I was looking for some stock because I just really don't have much stock to work with. I think that's about as long as I should make it. Well, this is going to be the funnest thing I've done all day, I'm telling you. This is a lot of work for a boy that sits in front of the computer all day. You know, you always feel like you're getting somewhere when you get the hacksaw blade down below the surface of what you're cutting. Finished. Hope I don't have too much material there. Ooh, I got a lot hanging out. It's about as much as I dare, but at least this is aluminum. That's a little better. Try to use this tool for facing, see how it goes. I don't know how centered I am. I need to set that up first to get it close. Wow, I'm way low. Now, one of the gambles I took when I bought this tool post, I thought about buying a BXA because anything bigger and stiffer is better, but I kept myself from doing that. But I did buy the biggest tool holders that would fit in here. So these are 1/2 inch. I don't know that most people do that. Maybe they do. But I'm glad that I'm able to get this up to the center. It could have been a gamble by going big like that. I wonder if you could use a BXA on a lathe this size. You know, it looks like I'm about on the center. I think we can give that a try. And we're going to have a intermittent cut here to begin with because of my rough job of cutting off the shaft with a hacksaw. Oh man, this sounds so good already. This is probably about as far as I dare work outside the chuck. Looks like a little bit of a crazy distance, doesn't it? This might be the cleanup pass. Nope. Beautiful. Facing operation. It's a miracle. Okay, this project's already going smoother. Alright, when I looked at this lathe, it had a noise in the gear train. And this is vibrating very heavily compared to these other studs. And I don't feel any slack from here to here. Now what adjusts that is the shifter gate on this side. I'm not sure what Atlas calls it or Clausen calls it, but I'm going to call it the shifter gate. Well, you see the slot in this plate, and this plate has the holes that position this. Well, this is literally moving the gears in and out from the spindle pinion. There's there 4 positions on that? So that's reverse, neutral, forward. Oh. I'm confused. Oh, that's not a hole down there. Okay. So it's supposed to be there. And now we got, listen to that. We got huge amounts of slack. And notice this is adjusted up all the way. The gap in this slot is up high here. So let me move this down. Hopefully it'll move easily. Ooh, I'll say. I'm just going to set it by slack over here. Just a little bit of slack there now. Let's come over here and I'll show you in a highly technical manner how I measured this. A little bit of perceptible slack. I'm not sure if it'll be quieter, but it almost has to be. Ah, listen to that. Don't do this if you don't have any extra fingers. Sounds a lot better. Here's something I've been wanting to do. Who knows how much gunk and oil, how many chips and stuff is in the oil. It's been on those gears for how many years. Now we don't have any lubricant. I can always redo this. I'm not sure what the ideal lubricant is here. And if you're concerned about having your fingers around these gears, make your wife do this project for you, okay? Look at that. Look at that marvelous beam footage. Wouldn't it be beautiful if aluminum stayed like that all the time, like fresh turnings? You know, I never adjusted the height of that tool. Oh yes, I did. I did when I faced it off. Looks like we're getting a good cut. Okay, that's plenty. Back the tool bit out. Let's look at what we got. Take the power feed off. It's not perfect, but I'm learning. Okay. Get the tool out of the way. I'm going to come in here and hit this with the center drill again. Time to drill this out. We got to get a 750 hole in it. Wow. Guess I could use a bigger chuck. You know what? I just might own a bigger chuck. Why yes. Why yes I do. Here's the chuck. Came with my Craftsman lathe I'm restoring that my dad helped me get. I may not have the right chuck key here. Gotta love that wrench. Just love having that wrench on the lockdown here. The lockdown for the tail stock. Got a number of drill bits in a metal tray, green metal tray you saw. It's amazing how tight it felt like I could get that chuck just with my hands. I'm going to give these a try. I got these bits with the vintage benchtop drill press, and let's see. How am I going to know how far I drill this? Okay, I'm looking at a mark on the ram. Might be turning just a bit fast. Oh, we're slipping in the chuck. Of course it's not tight enough. It wasn't properly tightened. a little farther, just in case I make two washers. I have room for the cutoff tool. Chuck up. Take this initial bit out, and I'm going to remove the chuck. Something I've never done before. I'm going to drill with a drill bit. I've got a few of these now that have a number 2 taper on them, number 2 Morris taper. So I'm going to do one more undersize bit. This one's 5/8. Until I hit the bottom of the hole because it started drilling more slowly. 3/4 bit. Bet you I'm going to slow it down. Let's see. Ooh. Doesn't sound like it. There I'm at the bottom of the hole. Didn't sound horrible. So that's about 1 9/16. So yeah, I'm going slightly under 1.5 inches here, so I don't want to go any smaller. Now in this stamped piece of sheet metal, what I'm concerned about, if I decide to put a washer underneath, is how thick is this? Did they roll this metal into this hole? And I can feel underneath, and yes, they did. So if I measure the thickness of the sheet metal on the lip here, it's 1/38, so it's a little over 1/8. If I measure the apparent thickness inside this hole, I don't know if I can do that. It's quite a bit more than that. It's at least 1/4 inch. So if I want to put a washer on the bottom of this, and I think I do, I need to know the outside diameter of this snout that's heading down here. And let's see how I can measure that without getting myself down in the dirt completely. That's 9/15, so the bottom washer has to have a hole that's 9/15 or larger. So let's cut off the top washer here first. Now another measurement that we want, the nut only goes down to 400 thousandths. So if the total of my washers is 3 to 400 thousandths, it'll be I'll be able to tighten it up on that flange. I didn't measure the thickness of the flange, but it's at least 200. And I am going to radius this edge with a file. I need to, each time I use one of these tools for the first time, I got to raise it up to the center of the part. I don't have a center finder yet, so I'm kind of doing this by eyeball. That looks about right. Since I've got a hole in the part, it makes it a little bit less critical. If I was cutting off a solid piece and I was a 1/16 below center, it would leave an 1/8 inch diameter stem connecting the part. But since I've got a hole there, it's a little bit forgiving. Now let's see, how wide is that bit? It's 95 thousandths. And we don't have to be super accurate with this stuff. I want to mostly, I think, raise the ball up because the tractor's got a pretty low mounting point. So I'm going to make this, I think I'm going to make the bottom washer about 150 thou, and I'm going to make the top washer about I'll make the top washer about 100 and the bottom washer 150 and the top washer about 250. So let's do the 250. And this is so non-critical. If I can just use the calipers as an eyeball gauge to set that. I can also do it this way. Oh, I'm moving it. Yeah, that's 258. 258's fine enough for me. And let's see, I made a mistake. I haven't squared this tool to the chuck. Let me do that. What is the carriage running into here? Carriage doesn't want to go that far. Here. We can do this another way. I'll use this 1, 2, 3 block. I may have done this when I set it up. It was late at night. Wow, it looks perfect. I think I did this when I tightened this tool post up originally. So I think we're okay. So now we can go back and find our 250. Let me just set the tool to 250. You know, I have a new battery. There we go, tool's at 252. Close enough for the kind of mowers I buy. Right there. Close a dang enough. And let's see, do I want to hand feed this? Let's use the power cross feed. Let me come out here. I want to see how fast this is feeding before I trust it to do this. Ooh, that's moving right along. Wow. What am I doing wrong here? I'm in E range. Four thousandths feed. Per revolution. Wow, I think that feed rate's going to be way too fast. Let me lock down the carriage. I'm just going to feed this by hand. There's no point in me lock down the carriage. There's no point in me breaking this tool. I'm just going to feed this by hand. Okay. Put it back in neutral. Ooh, we got something loose here. There's no way this would have taken a feed rate like that. That's about as fast as that thing feels like it wants to feed. And before I cut it off, I'll straighten this out with the corners out with a file. looks happy.